Hey there everybody. So in this video we're going to start talking about our inverse circular functions. This video will probably be only able to get us to like the start of example 1 because I don't want to take it too long. Just want to review what inverse functions are and what one-to-one functions are. So remember, a function is a value that every domain value has exactly one y value. So a function says every domain, every x value has exactly one y. X will not repeat. So every domain value, which is usually our x values, our inputs, has exactly one y value. One range value. And my range value is my outputs or my y values. So remember, domain is my input, range is my output. Now, for a one-to-one function, a one-to-one function is still a function. So every domain has exactly one y. Every x has one y. Also, every range value has one domain value. What this means, my graph passes both the vertical and horizontal line test. So my graph will pass, oops, I didn't put pass. And probably pluralize tests. I like typing as we go, that way you can kind of see what I'm thinking. So to be a function, every domain of the function, every x goes to exactly one y. However, if I'm a one-to-one function, every x has one y and every y has one x. What that means is we will pass the horizontal and the vertical line test. So if we look at these two graphs, you can see, I already got my horizontal line up here. Let's make this a vertical line. So a lot of times if you take your pencil or your pen and you hold it vertically across the graph like this, you can see this graph hits the red line only once. So it is a function. The parabola is also a function. Every time the vertical line goes across the parabola, it hits the parabola in exactly one spot. Now, if we flip it, so it's now a horizontal line, x cubed is still a function going vertically. That means it is a one-to-one function. X squared, on the other hand, look, as soon as it starts to hit it, how many times is the graph hitting the horizontal line? It's hitting it twice. That means x squared is not a one-to-one function. It's not a one-to-one, like if we put in -2, we get out a +4. If I put in a +2, I also get out a +4. Look at that, we get those, the range repeats itself. It repeats itself here. It repeats itself here and here. The range repeats itself. And those are the values they gave us down here, and it does it continuously. So what we often like to do is to make a graph one-to-one. It makes the function, it makes graphing its inverse a lot easier. Is we will restrict our domain. We're going to say, instead of looking at the entirety of the parabola with a domain of -infinity to infinity, we're going to say, you know what? Let's not do that. Let's ignore half of the graph. Let's only look at half of the graph. Let's restrict our domain to 0 to infinity. Let's only look at this portion of our graph. And that way, my function is a function, and the inverse is a function. This is a one-to-one function now. Because we restricted it, we are now looking at a one-to-one function. Why do we care? Alrighty, because you can see by looking at y equals sine x. right here. We can see that it's a function. It passes the vertical line test, but it's not one-to-one. Also, if we make a value of its points, let's make a t-chart from the graph. What we're going to notice is none of the domain values repeat. There's that point right there. We're going to do this point, negative 3 pi over 2 kicks out a 1. But you'll notice something here right now. If I plug in a negative pi, again, I get out a 0. My range values are repeating. This graph is not a one-to-one graph. If I put in a negative pi over 2, our range is negative 1. Plug in a 0, get out a 0. That's that point right there. Pi over 2. Get that over. Pi over 2 gets out a 1. Pi is a 0. 3 pi over 2 is negative 1. And lastly, 2 pi is 0. None of my domain values repeat, so it's a function. My range values, however, do, so it's not one-to-one. It just makes, we're going to get to it in a minute. Let's see what happens when we graph the inverse of my graph. Even though this says x equals sine y, that's how we replace it. We usually find, so we're going to graph this. What we're actually going to end up graphing is y is arc sine of x. I'm going to write it like this because now what's going to happen, because my x values still go on the horizontal axis, my y values go on the vertical axis. But what happens is, you'll see what's going to happen. Watch this. So let's plug in a 1. If I plug in a 1, it's going to get negative 3 pi over 2, because to graph the inverse, we just switch x and y. We're going to plug in a 0, and that's going to give us negative, oh my goodness, negative pi. I just put all these points in the wrong place. Negative 2 pi, negative 3 pi over 2, negative pi, plug in a negative 1, and we're going to get negative pi over 2. Plug in a 0, get out a 0. Plug in a 1, get out pi over 2. Plug in a 0, get out a pi. Plug in negative 1, and we're going to get 3 pi over 2. Yeah, this is getting a little messy. And then we're going to plug in a 0, to which we get out 2 pi. Because now the end, then when we connect our dots with our sine wave. Sorry, my brain's kind of all over the place. There we go. What we can see now is, while the original function, the original graph is a function, the inverse of that graph is not a function. So what we are going to do is we are going to end up limiting our function. Alrighty, we're going to end up, went backwards instead of forward. We're going to limit our function. What we want is we only want one part of the graph where my domain and my range do not repeat. So for my original graph, we're going to go from negative pi over 2, negative 1 to pi over 2 and 1. And then that means on my inverse, that would be that portion. So take a look at it. What do we limit our y's to from least to greatest? On this graph or on this graph, what do we limit our y's to? Well, since my sine was not a one-to-one function, therefore the inverse is not a function at all. So we have to restrict that domain. And what we're going to do is, when we have our inverse function, we want y to only return values from negative pi over 2 to pi over 2. Those are the ones closest to 0 right here. From this point, negative pi over 2 to pi over 2. Negative pi over 2, pi over 2. Those are the values we want restricted. Plugging in a negative 1, we're going into a 1, we're going to get one group of our graph, because then if we turn any corners, it's not going to be a function. All right, so we're going to limit our domain to these values. So that means we're going to go from quadrant 4 up to through quadrant 1 when we graph these. So remember, our inverse trig function, y equals arcsine x, is asking you to find the angle y in the interval whose sine is x. All right, so what I'm going to do is when we come back, we're actually going to go through example number 1. I just wanted to go over what it means to take an inverse and why we want it to be a one-to-one function when we do. If you have questions when we get to class, please ask them.